Hello guys, welcome back to my channel. My name is Sushwa Saitar. I hope you all are doing fine. Let's solve today's problem for Leetcode. The problem name is convert sorted list to a binary search tree. Okay, it's a medium problem. Let's give a like. The problem is saying given the head of a singular linked list where elements are sorted in ascending order. So we will be given a linked list where the elements of the linked list is in sorted array in ascending order. Okay, convert it into the height balanced binary search tree. So what we have to do, we have to convert a linked list which is sorted in ascending order. We have to convert it to the binary search tree. Okay, so we understood the problem. Let's see what is binary search tree, height balanced binary search tree. Let's assume we have there's a three rule, no, basically two rules. So one rule is that the left side should be always less than the root value. Okay, and the right side should be always, wait, the signal is wrong. Okay, the left side should be always less than the root value, and the right side should be always more than the root value. This is the basically binary search tree. So what do you mean by this? Let's take an example. Let's say we have example like say we have 0, and at so in this condition it should not be more than the root value. Now what is this? This is the root value. Okay, this is the root value. The left side should not be more than the root value. So we can either take whatever the value comes less than 0, we can take, which is -2. And then what at right side? The right side should be more than the root value. So any element which is more than the root value is considered, we have to put it to the right side. Okay, let's take this one. Let's take 2, positive 2, so which is more than 2, and negative 2 which is less than 0. I hope I'm clear here. So this is, what is this? This is left side, and what is this? This is right side. So this condition is satisfied. Let's go deeper. So here what will be the left side and what will be the right side? Can you tell me in the comment? Okay, the left side will be obviously less than 2. So what is less than 2? -3 is less than 2, or -1 is less than 2? Obviously -3 is less than. So if you go negative, it will be opposite. Okay, -3. And what will be the right side? We can put -1. Same thing we will do for this side. So this like we have left side, what we have, we should be less than the root value. So only one thing is that, which is 1, and the right side should be more than the root value. We can put it here 3. Okay, I hope you understood what is binary height balanced binary search tree. I hope you understood here. What is this? It has same whatever the left side has, obviously right side also has. So it is a height balanced binary search tree. Okay, I hope I'm clear here. Let's see what this example says. So we are given in a linked list and we have to convert it to the binary search tree. Okay, so we are given here a binary tree. We have given a linked list, so we have to convert it to the binary search tree, height balance binary search tree. Okay, so like we can take here 0, and here at left side, is this less than the root value? Yes, it is less than the root value. So we can say it is right, and at right it is more than the root value. Yes, it is more than the root value, so it is also right. And next we will check for this one. This is left is less than the root value. The left should be left always less, so it is right. And here this is the root value, the left should be always less, so here we have -10, so this is right. So we can say this is height balanced binary search tree. Okay, this solution satisfies that. Let's see how we can solve it. Before that, what we will do, I don't want linked list, I want to convert it to the array list. So what I will do, first I will convert it to the array list. It will be easy for me. So I don't want to solve it with linked list, so I'm just converting into the array list. So let's create array list here. So integer, and I will name it as array new array list. Okay, so now what I will do, I have to iterate to every element. So let's say this is head now. Okay, so this is head now. I have to iterate everyone, I have to keep on adding. Okay, so for that, which function, which loop I should use? I should use while loop. While head is not equal to null. What is null? Like we don't have any element, this is considered null. Till then run this loop. Okay, till then run this loop. So what I will do here, I will just okay, so what I have to do here, I have to keep on adding the element. What element? I have to add head dot value. So value is here, it is value, so we have to put value here. Okay, after that, what I have to do, I have to now emit this, and the head should be here. For that, what I will use, I will use a function called nest. Okay, so now head will point head dot nest. Okay, what I did here, now head was here, now head will be here, now again head will be here, again head will be here, again head will be here. Now here the nest will be 0. Now it will stop. Okay, I hope I'm clear here. Now what we did here, we just created array list. Okay, we just converted a linked list to the array list. Okay, now we will create a function which will help us, we will call it helper, so to make it to the binary search tree. Okay, array, and the starting point will be 0 and the ending point will be the size of the array. Okay, so why I'm doing this, I will tell you. So let's see. So I hope you remember, whenever we see a sorted array, we have to solve it by binary, this one binary problem, or we can say we can say divide and rule. So there are many names, so basically like divide and rule, so we will take that. So divide and rule. So what is the meaning of divide and rule? So let's take this example only. Let's take this example, and what I will do here, I will remove this. I don't want this. I will create my own answer. Okay, so what I will do here, I will consider left has 0 and the right has the maximum value. Okay, now what I will do, I will find the mid value. So what is the mid value here? The mid value is here 0. So how can I find it? So like L, to find the mid value, so basically what we have to do, we have to add the low value and the last value and divide it by 2. So in this case, what we have to do, this is 0, this is 1, this is 2, this is 3, and this is 4. Okay, so here 0, so what is the last value, which is 0, plus what is the value last, 4, and divide it by 2. Okay, now the value will be equal to how much? The value will be equal to 2, because 4 divided by 2 will be equal to 2. So what will be the root value? So I will create here. Okay, so now the root value is here. What is the root value here? Root value is 2, which is 0, so we will make 0. Okay, now again we will do here, what we'll do here, again we will find the mid value, but what I told here, the rules here, the left side should be always less than the root value. So what I will do here, I will say you have to calculate from here, we have to calculate only this element. So what is this? 0 plus 1. What is 0 plus 1? Which is equal to 1. Now divided by 2, which is also equal to 0, because we don't consider decimal point. So what is 0 here? 0 is minus 10, and where it should be? It should be at the left side. Okay, it should be at the left side. Let's create minus 10. Same thing we will do for the right side. So from here, right side, so we have to take from here till here. So what is 3 plus 4, which will be equal to how much? Which will be equal to 7. So 7 divided by 2 will be equal to 3.5, and we can say it as 3. So what is 3 here? The 3 is here 5. So what we'll do, at the right side we will put it as 5. Okay, At the right side, we'll go and put it as the 5. Okay. I'm clear here. I hope till here you understood what I did. I just divided both the element. Divide and do. Now, here I have calculated here. So I have to find only this length. And we can say this is minus 3. So minus 3 is more than minus 10 or less than minus 10? Obviously more than minus 10. So what we will do here, if it is more than the root value, what we have to do here, we have to put it at right side. We have to put it at right side, minus 3. I hope I'm clear here. Let's search for this one, and we have another value which is 9, and 9 is more than 5 or less than 5? Obviously more than 5. So what we'll do, we will put at 9 here. Okay, so this is the solution for this. But here you can say it is quite different here. Here it's quite different, but the solutions are same. But the solution will be approved because here they took 3 first, then they went for the minus 10. But here we took divide and rule concept and we did it. Okay, let's see if the solution accept this order or not. Let's create a public. What we have to do, we have to return the tree node. Okay, why we have to return tree node? We have to return at the end of the tree node. That's why we are creating tree node. And what will the function called? The function will call helper. And I'm quite lazy, so I'll copy this and paste it here. And the int will be the left side, and the int will be the right side. Okay, so I will just take this length, make it more elegant. Okay, let's do it. Okay, now what we have to do, we have to first find int mid. So how we can find it, how we did it? Left plus right divided by 2. Okay, we just divided it. Now what we have to do, we have to go and add it to the array, root array. For that, what we'll do, we'll create tree node root equal to what? New tree node array dot get of mid. So that's why I converted to the array. So we can't get the middle element. We have to use like slow mid for linked list. We have to use you may have heard about slow and fast. So I don't want to use that. So this is quite easy. So I just converted it to array, and this is the pure solution. Okay. After that, what I have to do, I have to go to the left side. And here what I did here, I said now the mid minus 1, which is was mid. So I create mid minus 1 will be your new right side, and the left side will be same. Okay, the left side will be the same. Root dot left will be. So now we will recall the function here. We will recall this helper function. We will recall the helper function, and we will say array will be the same, and the left will be same. But here what we modified, the right value. The right was here, and now the right was here. So what we will do here, it is mid minus 1. I hope I am clear. And same thing we will do for the right side. Same thing we will do it for the right side, which is helper array. Now here we modified the left value. So what we will do here, we will place mid plus 1. So what here, first it was mid here. So now we take left as 3. So what we will do here, mid plus 1 comma the right side. And at last what we have to do, we have to return the root value. Okay, let's run and see, is this solution acceptable or not. Let's run. Okay, so here there was some mistake, because the loop will keep on running. We didn't created a stop value. So what we'll do here, how we can create this, how we can stop this, if left is less than the right. So what we can say, so in this case the left was less than the right. So what we'll do, we just return the null. So what we'll do here, if left is more than, so what we can say, if left is more than the right, no, we can say, okay, If left is more than the right, then we'll do one thing, just return null. Okay, then don't do anything. Now I think so runtime error will not come. If there's any error, anything else, so it will come. Yeah, it's getting accepted. So as you can see, the output they wanted here, so what my output was 0, -10, 5, null, -3, null, and 9. But they were accepting, they wanted -3, 9, -10, null, and 5. But as you can see, this is also a height balance binary search tree, so this solution is also accepted. I hope I'm clear here. Let's submit and see if there is any error. So now you can see it is getting accepted. So it is getting accepted. I hope I'm clear here. I hope this solution is quite easy for beginners, and also you have learned some new things. And if you like this video, please do like, and if you didn't understand any part of these questions, please do comment. I will surely help you. And thank you for watching. Keep coding. Chalo, bye.